So first we consider any function. It may be algebraic function, it may be logarithmic function, it may be trigonometric, any arbitrary function. It may be x cube minus 3x plus 2, it may be 1 by x square minus 1 by x cube, like this. Now first, if I plot a graph of this any function, I want to plot this graph. So I don't know which type of graph it will show. So I will just consider an arbitrary graph. And let us consider the graph will be like this. It may have some other repetitions like this, maybe, so on. So I find this graph for any arbitrary function. Now, we have to first find out the points where the tangent to the graph is a horizontal line to the x-axis. This is our x-axis. This is y-axis. Tell me how many points are there in the graph as in between this graph. There may be some other points where also tangent may be horizontal, but they are not in the range that is specified in the graph. As this graph is presented in the board, tell me how many points are there where the tangent to the curve is a horizontal line, means parallel to x-axis. 3. So one is this point, one is this point, another is this point. So at these 3 points I can consider this. If I draw a tangent, that will be a horizontal line. This tangent will be horizontal. So what is the slope of this tangent line? 0. Slope of a tangent line means, straight line means dy dx. So dy dx 0 means line is horizontal. So at this point I can consider dy dx equal to 0. At this point also dy dx 0. At this point also dy dx 0. Now if I have that function and for any, this graph is arbitrarily given to you, but suppose a very complicated function is given to you, can you plot the graph easily? So in this graph we can see the graph and find out at which points the tangent will be horizontal. But if the function is very complicated and we cannot draw the graph, then we cannot say at which point the tangents are horizontal. Then without drawing the graph, we have to adopt some other procedure. What? Suppose the functional form is given, y equal to say x to the power 3 minus x cube, x square. So don't plot any graph, just calculate dy dx. So it will be 3x square minus 2x, and set this dy dx equal to 0. Just put dy dx equal to 0. So I will write it in a different manner. Dy dx, I will set this equal to 0, because we know from this that whenever the tangents are horizontal, dy dx will be 0. So I will set dy dx equal to 0 and I will find a equation. I will get a equation that is 3x square minus 2x equal to 0 in this particular example. Then we can say the value of x. Taking x common, I can write 3x minus 2 equal to 0. Means there are two values of x that I find, x equal to 0 and 2 by 3. So there are two possible values of x where the tangent to the graph will become horizontal. Clear? This is an arbitrary graph. If we plot this graph of this function, I will get 2 points where tangents will be horizontal. It may be a 4th order curve, means x4 is there, then we will get 3 points where tangents are horizontal. If it is a 5th order curve, means equation is 5th degree, then there are 4 points where the tangents are horizontal. Okay, it is a 3rd order curve, so 2 points we find. If it is a 4th order curve, we find 3 points like this. Now, you may say that it may not be an algebraic function, it may be e to the power x sin x. Okay, that is a complicated function. For that we will get many such horizontal lines. Now, these points in a graph where tangents are horizontal, they are named with a special name called stationary points. Means the graph that I describe here, this point, there is suppose certain x values of this point, x coordinate of this point is a stationary point. This point is a stationary point. This point is a stationary point. Now, why then, how the name comes? Stationary points. What do you mean by the word stationary? Stationary means not moving. It is at rest. Now think of, suppose a mountain climber is climbing and reaches this point. So now if I ask you whether his climbing is complete, what you will say? Climbing completes to this point, peak completes. Okay. Now, whether his downward movement begins? No. So, ascending completes, descending not started yet. So, what will be his condition now? Stationary. So, that's why the point is named as stationary. Now, same thing. Descending completes, but ascending is not started yet. So, again he is stationary. So, both of these points are stationary. And at both of these points, first derivative of the function will become 0. So, first derivative of the function 0 at both the points. So, that means by taking first derivative equal to 0, you can only find the stationary points, not the maxima and minima. You cannot decide whether that stationary point corresponds to maximum value or corresponds to the minimum value, whether it's a peak or it's a valley. You cannot decide from first derivative equal to 0. The same thing, by saying force equal to 0, you can say only equilibrium. Equilibrium means net force 0, that is the stationary in physics. But you cannot say whether it is a peak of the potential or it is a valley of the potential. Valley of the potential means minimum potential, and peak of the potential means maximum potential energy. Clear? Now, why I emphasize with the first derivative with the force? Because potential energy's first derivative will be force. Because we know that, suppose you know that potential energy for a spring is half kx square. Take the first derivative of potential energy, du dx. It comes out what? Kx. Now take negative of this, means Hooke's law. F, this is the force. For a spring force, Hooke's law, F equal to minus kx. So negative derivative of potential energy means force. So that's why we are emphasizing that first derivative and the force equal to 0 and force equal to 0 are similar. Because force equal to 0 means potential energy's first derivative will be 0. So from that you can only consider where potential energies are maximum or minimum, those stationary points where maximum and minimum lies. But you cannot say which one is maximum or which one is minimum. For that to decide, we require the second derivative. Okay? Now, is this concept clear? Because this is a very important concept in physics, and this is a concept of coming from the mathematics. Most of you think that mathematics is very bad subject and it is not at all required for doctors. But remember, this, without this you cannot solve the physics problems. And I don't believe that doctors are very bad in mathematics. Suppose you have to operate, you have to cut 3 millimeter, and doctor is unaware of the measurement, units and measurement or this. He cut like this. Okay. See. So now we have to check the second derivative. How? Now many of you have the confusion that you studied already that at the maximum value of a function, near the maximum value, the double derivative will be negative, and near the minimum value double derivative will be positive. Now it creates bit confusion that near the maximum it should be positive, near the minimum it should be negative. Normally people believe that, but that is not true. Why? See, this is a stationary point. So just before this, reaching this stationary point, I want to draw a tangent. Now tell me, if I calculate dy dx at this point, is it positive or negative? It is positive. Why positive? Because see, if you extend this, it will cut the x-axis at an acute angle. Acute angle means tan theta will be positive, because in the first quadrant all trigonometric ratios are positive, so tan theta is also positive. So dy dx is positive, means greater than 0. Just after this stationary point you draw another tangent and check whether at this point derivative, what is the sign of the first derivative? See, it will cut at an obtuse angle, means in the second quadrant. In the second quadrant tan theta will be negative. So at this point dy dx is negative. Okay. So I denote this one as dy dx initial value, and this is dy dx's final value. Dy dx final minus dy dx initial. Now just check dy dx final minus dy dx initial. What is the sign? Final minus initial means change in dy dx. Final value is negative, initial value is positive. Suppose final value is minus 2, initial value is plus 2. So minus 2 minus 2. So it will be negative. So negative, from a negative value you are subtracting a positive value. So entire value will be negative. Now what you are calculating? Final value of the dy dx minus initial value of the dy dx, means you are calculating change in dy dx. So what is dy dx? Change in y with respect to x, and you are calculating its change. So change of change. Change of change means double derivative. Change means first derivative dy dx. You are calculating the change in the first derivative. Change in the first derivative means second derivative. So that's why we are saying that d2y dx2 less than 0 near a maxima. dy dx initial minus dy dx final. Dy dx itself means change in y with respect to x, and you are taking the change in that derivative. So change of y with respect to x. So change comes twice. So it is second derivative. Okay. So the second derivative is negative, means the value is maximum. So obviously, if you draw the tangent here, and here, what happens? This is initial, this is final. Now final is positive, initial is negative. So suppose final is plus 3, initial is minus 3. So 3 minus of minus 3. So it will become plus. So near the minimum value, d2y dx2 will become positive. Final value is positive, initial value negative. So final minus initial means, suppose plus 3 minus 3 to plus 3. So 3 minus of minus 3. So entire thing will be plus 6. So that's why near the final minimum value, double derivative sign will be positive. Okay. Now you can check this function. So I have already calculated the stationary values. Now I will check from this, calculate the double derivative. Okay, is this entire part written? Now I want to calculate the double derivative from this and check at these 2 points whether they are positive or negative. So double derivative of this function will be d2 y dx2, that is equal to 6x minus 2, right? Now check the double derivative sign for two values. First, at x equal to 0, if you put x equal to 0, it is minus 2, that is double derivative becomes negative. So negative means maximum value. So at x equal to 0, that function has the maximum value. What is the maximum value of y? Then calculate. Y max, by putting x equal to 0 here, it will be 0. So first we find the stationary point, then for those stationary points I will check the sign of the double derivative and decide for which stationary value it comes maximum and which stationary value it comes minimum. Then in the original function we put that stationary value and find the maximum value of the function or minimum value of the function. That is the case. Okay. Now check the second one, d2y dx2, other value is x equal to 2/3. Check, 6 into 2 by 3 minus 2, that is 4 minus 2 plus 2. Plus 2 means greater than 0. Greater than 0 means minimum. So at x equal to plus 2, this function y has a minimum value. So calculate y minimum. That will be 2 by 3 whole cube minus 2 by 3 whole square, that is 8 by 27 minus 4 by 9. 27, that is 8 minus 3. So it will become minus 4 by 27. What to write? Anyway, y minimum minus 4 by 27. See, that is minimum and 0 is the maximum. Okay. Now minimum value is minus 4 by 27. Maximum value of the function is 0. Clear? And if it suddenly comes that double derivative is also 0 at every point, means irrespective of the value of x, double derivative comes to be 0, then what happens? Means you cannot decide whether it is maximum potential energy or, so everywhere potential energy remain, that is the neutral equilibrium. Now neutral equilibrium means body is moving over a surface, means it's a straight line, it should be two-dimensional. Double derivative 0 is always giving you a equation of a straight line. How? See, I will not, new page. See, whether you will get double derivative equal to 0, 0 means d dx of dy dx, that is equal to 0. So if the derivative of any function is 0, then the function is constant. So write dy dx equal to constant, dy equal to m dx, there should be some integration constant, equation of a straight line, means the particle is moving on a horizontal surface. Suppose a ball is moving on a horizontal surface, so its center of mass is always at the same height, so if it rolls, it moves along a straight line, so that signifies stable equilibrium, neutral equilibrium. Okay, so double derivative 0 means it's a neutral equilibrium, but it should be at every point 0, not a particular point. Double derivative at a particular point 0 is different, that has a different meaning. Okay, now I will give you one function, another function to calculate the maxima minima. Previously we calculate maxima minima, all the steps are clear. First, when you get the function, first calculate first derivative. After calculating first derivative, set dy dx equal to 0 and solve to find the values of x. With those values, calculate also the second derivative and check the sign of the second derivative with those values. Then for that, which if it is for a particular value of x, that is a stationary point, the double derivative comes negative, for that value the maxima exist, and for the double derivative sign to be positive, for that value minima exist. Okay, now for this function, show me y equal to x plus 1 by x. First calculate dy dx and then d2y dx2, calculate both and then proceed to check all these things. Check, it will give you ridiculous answer. Maximum value is coming -2 and minimum value will come +2. Maximum value is less than the minimum value. Maximum value -2, minimum value +2. Normally we think that maximum value should be +2 and minimum value should be -2, but here the condition reverses. How will you explain? that maximum value for this is -2, where the minimum value will be +2. It all comes from the graph. If you plot the graph of this function, that function y equal to x plus 1 by x. So I will take another. I will consider 3 different curves. First one is y equal to x. It is just a straight line at an angle 45 degree passing like this. Y equal to 1 by x. You can think of that this is like a Boyle's law. You have already studied P versus 1 by V graph. It's a rectangular hyperbola. So graph looks like this. But here x and y are not pressure and volume, so I can also plot in the negative axis. Okay. Now, the actual graph that is given in this problem is, equation is this one, y equal to x plus 1 by x, means both functions are added. So what will be the nature of the graph? This will be the nature of the graph. Now you can say that how you know this nature. This will be the nature of the graph. Okay, see. If I go to a very large value of x, then 1 by x will decrease. So which value will be larger? X. So the nature of the graph will be more likely to this one. See. If x is very large, so the 1 by x term will be going towards 0, and the nature of the graph will be dominated by this term. So the graph looks like a straight line. See, the appearance of a straight line is present in the graph. Now, if you go to a very small value of x, then this first term will be very small, but 1 by x will become very large. It has tendency to go towards infinity when x tends to 0. Yes. Okay. So for small values of x, it has more similarity with this. For large values of x, it has more similarity with that. Now check from this. Where the minimum value lies? In the first quadrant. Where the maximum value lies? Third quadrant. So minimum value, maximum value. That's why this comes. Maximum value of the function lies in third quadrant, so it is negative. And minimum value of the function lies in first quadrant, so it is positive. Though it looks ridiculous that how minimum value can be greater than the maximum value, but graph shows that it actually happens. Okay. So whenever in a physics problem you will get the potential energy in that particular problem, A by r square minus B by r. So what we have to do? First derivative equal to 0 and solve for finding the stationary points, and then with those stationary points calculate second derivative and check its sign to find the stable equilibrium. Stable equilibrium means potential energy function u will be d2u dx2, that will be stable, means minimum potential. Minimum potential means second derivative will be positive. So check. Now solve the problem. U is given, first calculate is first derivative, that is du dr. It will be r to the power minus 2 actually. So it will be a minus 2 r to the power minus 3, that is r cube, and this one will be minus b, and this term will be minus 1 by r square, its derivative. Because second term is b by r, means r to the power minus 1, its derivative will be minus 1 r to the power minus 2. So it can be written as minus 1 by r square. Okay. Now from this you can simplify and write d2 du dr equal to minus 2 by r cube plus 1 by r square, minus 2 by r cube plus 1 by r square. Sorry, a and b are there. 2a by r cube plus b by r square. Now for finding this equilibrium position or stationary points, du dr should be 0. So putting du dr should be 0, you can write 0 equal to minus 2a by r cube plus b by r square, means 2a by r cube equal to b by r square. So what is the value of r from this? I can cancel 1 r square r, so r will be 2a by b. So this is the stationary value. Now if it is so what is given in the problem, asked in the problem? Stable equilibrium. So whether this value corresponds to stable or unstable, that you have to check now. So from this step, calculate the second derivative and then put the value of r and check the sign, whether it is positive or negative. If it is negative, then it is not stable. If it is positive, then it is stable equilibrium. Normally in problems, if options are given, then if this option r value of r will come, no need to check, because they are asking for stable equilibrium, and if the option matches, you can already tick. But for safety, you can check the second derivative sign. Because here in the problem it is mentioned stable equilibrium. Suppose some value of r is given and you have to check whether it is stable or unstable, then you have to definitely check the sign of the second derivative. But in this problem we can bypass the second derivative sign calculation. See, d2 du dr equal to minus 2a by r cube plus b by r square. So du dr equal to minus 2a by r cube plus b by r square. So if I take the second derivative, d2u dr2, this will be minus 2a. Now this is r to the power minus 3 actually, so its derivative will be minus 3 r to the power minus 4 plus b into r to the power minus 2's derivative, so minus 2 r to the power minus 3. So this one will come to the 6a by r4 minus 2b by r cube. Okay, 6a by r4 minus 2b by r cube. Now the stationary point we have already found, d2u dr2 d2u dr2 at r equal to 2a by b. So I will put this value 2a by b in place of r. So it will be 6a into 2a by b. So b will be in the numerator. So b to the power 4 by 2 to the power 4 is 16, a 4 minus 2b into r cube, that is b cube divided by 8 a cube. Okay, b cube by 8 a cube. This comes, so 1a can be cancelled such that it will be a cube, and then I can cancel 1 2 from this, that is 3 and that is 8. So this cancellation I will not do here. Take 8 a cube in the numerator, it will be 3b4 minus 2b4. Okay, so that is b4. A and b are mentioned as positive constant, so this value will be greater than 0. Greater than 0 means minimum, so that is stable equilibrium. So r equal to 2a by b, a corresponds to the point of stable equilibrium. Because b and a are mentioned as positive constant, so b cube by a cube, b4 by a cube, that is also a positive value. Okay. So tornado is blowing over some people's head. Write down. Question number 21. A block is left on a frictionless curved path. A block is left on a frictionless curved path that connects to a horizontal path. That connects to a horizontal path. At the end of the horizontal path, there is a spring connected. There is a spring connected. Find the work done by the spring when the block, find the work done by the spring force actually, spring force when the block compresses it completely. Compresses it completely. The diagram is given. On a horizontal curved path. Curve. C-U-R-V-E. Curve. That connects to a horizontal path. At the end of the horizontal path, there is a spring connected. Find the work done by the spring force when the block, find the work done by the spring force when the block completely compresses the spring. Okay, diagram is given. It's a smooth path, curve. Block is released from here at a height h. This is the spring having spring constant K. The mass of the block given M. There is no friction in any portion of the path. Options: minus mk by h, minus mgh, m k by h. Option? Correct. Now, just a minute. Ek minute. Now, there is a change of sign. Minus mgh. Option B is correct. how many agencies are doing work in this case? First, the body is coming down, so work is done by gravity, and gravitational force is doing positive work, because gravitational force downward, body is also coming down. After reaching the horizontal platform, the body then compresses the spring, so spring force is again doing some work, but spring force is actually in the opposite direction of the displacement, so spring force must do negative work, because spring is compressed, so displacement of the body is along this direction and spring force is along this direction, so spring force is opposite to displacement, so spring force is doing negative work. So here you have to calculate the work done by the spring force, so that should be negative. Now we can write that work done by spring plus work done by gravity, that is the total work done, that should be the change in kinetic energy according to work energy theorem. Initially velocity is 0, when it is completely compressed, final velocity will be 0, so what is the change in kinetic energy? 0. Now work done by spring force plus work done by gravity, so what is the work done by spring? Minus mgh. Work done by all the forces is equal to change in kinetic energy, that is by work energy theorem. So here initial velocity is 0, final velocity speed is also 0, because initially it is about to fall, means 0 velocity. Final velocity means when it compresses the spring completely, then it again comes to rest. So both the velocities are 0, so change in kinetic energy will be 0. So total work done should be 0. So gravity is doing positive work, spring is doing negative work. So gravity's work is mgh, so spring's work will be minus of mgh. Okay. Write down. Question number 25. A block of mass m is attached to the lower end of a vertical spring, attached to the lower end of a vertical spring. The spring is hanging from the ceiling. The spring is hanging from the ceiling and has spring constant K. The mass is released from rest with the spring initially unstretched, with the spring initially unstretched. the maximum extension produced in length of the spring will be, maximum extension produced in the length of the spring, maximum extension produced in the length of the spring will be, option A, mgl by k, mgl by k, option B, 2 mgl by k, option C, 4 mgl by k, option D, mgl by 2k. एक मिनट not mgl, l is not there, mg by k, 2 mg by k, 4 mg by k and mg by 2k. That slash I considered as L. 2 mg by k. Can any one of you tell me why I can also calculate? So calculate the sum of these two and put a minus sign just to reverse the direction. Okay, sum of these two will be along this direction, so third part should have a momentum opposite to that and equal in magnitude, such that the total momentum is again 0, because since in the explosion the entire force is an internal force, there is no external force. Okay, so that's why we can consider the linear momentum is conserved. Now I want to ask you one question. Suddenly if a bomb explodes and all three parts are moving in a horizontal plane, can they completely move in a horizontal plane? There is gravity. So gravity is an external force. So how can we apply momentum conservation? Because linear momentum conservation is applicable only when there is no external force. So in this problem, how we can apply linear momentum conservation? There is of course gravity. Either you have to perform the experiment in a gravity free space, but such conditions are not given in the problem, still we apply momentum conservation. How? What is the logic behind that? See, whenever an explosion occurs, if any part coming from the bomb is moving, is it truly moving along a straight line, or it should move in a parabolic path following the projectile motion? Following the projectile motion, because it has velocity in this direction and gravity pulls it downward. So it should follow projectile motion. But now, when it explodes, the internal force is more stronger or the gravitation is more stronger? Internal force is huge in comparison to the gravitation. That's why we can neglect the effect of gravity and consider that with a short time span, it almost moves horizontally, not moving down too much. Because suppose if internal force is very small, the particle may move like this. And if internal force is too strong, what happens in case of an explosion? It moves quickly and after that it falls. So that's why within that time, if we calculate, we can say that the effect of the internal force is so strong, then we can neglect the presence of the gravity and treat the problem as if it is not acted upon by any external force and apply conservation of linear momentum. This is the logic behind applying conservation of linear momentum in case of explosion problems. Okay. Gravity is present, but still its effect is so small that we can neglect. Okay. A moving neutron, question number 42. A moving neutron collides with a stationary alpha particles. A moving neutron collides with a stationary alpha particles. The fraction of energy, kinetic energy, lost by the neutron, the fraction of kinetic energy lost by the neutron is option A 16 by 25, option B 9 by 25, option C 3 by 5, option D 2 by 5. Option কি কলিশন ধরেছো, ইলাস্টিক না ইনইলাস্টিক? ইনইলাস্টিক মানে কম্বাইন করে যাবে ধরেছো।
4n by 1 plus n whole square.
See, collision is perfectly inelastic. By considering that, you can solve. See, there can be two possibilities. In the question, it is not mentioned that whether it is perfectly elastic or it is perfectly inelastic. Because if it is partially elastic, then there should be the value of coefficient of restitution. But in this case also, we can calculate two procedures, two different values. In the problem, it is not mentioned in this book. So first consider the inelastic collision, then consider the perfectly elastic collision and calculate both the values. If you do both the cases, then you have already once there is a practice of both the collision problems. See, if a proton collides with a stationary alpha particle, so let us consider this is the stationary alpha particle, mass is considered as m2, this is proton, this is neutron, considered as mass m1. Okay. Now, if these two will collide, this is coming with, say, with velocity u1 and it is at rest, so u2 will be 0. If we consider perfectly inelastic collision, then what happens? After collision, both the masses combine together, forming a total mass m1 plus m2, and this combined mass moves with a velocity v. Okay. Then final kinetic energy kF, that will be half m1 plus m2 into v square. Initial kinetic energy will be half m1 u1 square, right? This is final kinetic energy by initial kinetic energy. Now, what is V? We can calculate V from conservation of linear momentum, that m1 plus m2 into V equal to m1 u1, and then this V will become m1 u1 divided by m1 plus m2. We can substitute it in place of kF, and then kF will become half m1 plus m2 into v square. V square means m1 square u1 square divided by m1 plus m2 whole square. So 1 m1 plus m2 will be cancelled from this calculation, and you are left with kF equal to half, that is m1 square u1 square by m1 plus m2, right? Now if you try to take the fraction of kinetic energy loss, okay, then calculate. Initial minus final by initial, that is the loss. So calculate this loss. So we can also take in this way, kinetic energy loss means initial is larger, Ki minus Kf by Kf, that fraction. So you can also write this one as Ki by Kf minus 1, Ki by Kf minus 1. Now what is Ki? Ki is half m1 u1 square, then 1 by Kf means 2 m1 plus m2 divided by m1 square u1 square, this minus 1. Okay, now this u1 square will cancel, 2 will cancel, and 1 m1 will cancel. So it will be m1 plus m2 by m1 minus 1. So this one will become 1 plus m2 by m1 minus 1. If I consider perfectly inelastic collision, then loss in energy.
Explain once more.
If I consider perfectly inelastic collision, then after collision they will combine. Combination will move with a certain velocity v. So I can find out that v by using the conservation of linear momentum, because in any collision linear momentum is conserved. So v will be equal to m1 u1 divided by m1 plus m2. Now final kinetic energy means after collision, it is half m1 plus m2 into v square. Initial kinetic energy is only for the first particle, m1 u1 square, because m2 is u2 is 0, so second particle doesn't have any kinetic energy initially. Now what is final kinetic energy? Half m1 plus m2, now v square. So this v square is substituted, so it is m1 square u1 square by m1 plus m2 whole square. 1 m1 plus m2 will cancel. Now we are left with half m1 square u1 square by m1 plus m2. Now if we want to calculate loss in kinetic energy of the neutron, because that is a neutron m1, so what will be its loss in energy? Loss in energy means final initial energy minus final energy. Loss means initial is higher, final is lower. So Ki minus Kf this one should be Ki. I divided by Kf. This one should be initial minus final, that is the loss, divided by initial. So how much fraction is lost? So from this we can write it is 1 minus Kf by Ki. 1 minus Kf by Ki. That is the loss, fractional loss. So 1 minus Kf. Kf is that one, half, it is m1 square u1 square by m1 plus m2. Now divided by Ki. Now what is Ki? Half m1 u1 square. So half means there is 2 and there is m1 cancel, m1 1 m1 will cancel, and it will be coming 1 minus m1 by m1 plus m2. Okay. this loss is coming 1 minus m1 by m1 plus m2. Ki minus kf is the loss in energy. Loss in energy divided by initial energy will give you the fractional loss in energy. So this is 1 minus kf by ki. Kf is that one, half m1 square u1 square by m1 plus m2 divided by ki means 2 by m1 u1 square. So u1 square cancel, 1 m1 will cancel and this 2 will cancel. So it will be m1 divided by m1 plus m2. Now come to the proton and neutron and alpha particle. M1 is neutron. Let us consider its mass is m. One neutron has mass m. So m1 equal to m. Now what is the mass of the alpha particle? We consider neutron and proton are of almost same mass. Alpha particle means containing 2 proton. So its mass is 2m. So in case of m1 I can put m, and in case of m2 I can put 2m. So it will be 2m plus m, that is 3m. So this will cancel and it will be 1 minus 1 by 3. So the fraction is coming 2 by 3. If you consider perfectly inelastic collision, it is coming 2 by 3. Now we haven't checked what happens in perfectly elastic collision. Okay, so if the collision is inelastic, then this comes. Now it may happen that the collision is perfectly elastic, means after collision they are separated still. So in that case what happens? Now we will calculate. Okay, this calculation is written. Check once again. We consider that neutron is colliding with the alpha particle and after collision they will combine together. If they combine together, they have a common velocity v. Since this collision is perfectly inelastic, we can only apply conservation of linear momentum. We cannot apply conservation of kinetic energy because in inelastic collision kinetic energy is not conserved. So using that conservation of momentum, I can find the velocity of the combined mass after collision. Okay, so this one. Now final kinetic energy will be this one, initial kinetic energy will be this one. Then we can calculate kf equal to this one. Now value of v is substituted from that equation. 1 m1 plus m2 cancel, it will be m1 square u1 square by half m1 plus m2. Now if I want to calculate loss means initial is larger, final is smaller, then it can be ki minus kf divided by ki. Loss means ki minus kf, fractional loss, how much part is lost. So for that I have to divide it by ki. Now it will be 1 minus kf by ki. Then we can substitute here and calculate and it will come 2 by 3. Now there should be many cases and the particular language of the problem matters. See, sometimes another part of the problem comes that final kinetic energy is how much fraction of the initial kinetic energy. That can also be given. Okay, see. I will not erase this. So if only this one is required, that is kf by ki, sometimes that is also asked in the question to calculate. Means final kinetic energy will be how much fraction of the initial kinetic energy. So in that case, for that particular problem, what is final kinetic energy? Check kf. It will be m1 square u1 square by 2 into m1 plus m2. So put it, and initial is half m1 u1 square. So if you just put this one, kf will be m1 square u1 square by 2 into m1 plus m2 divided by ki. Now check what is ki. m1 u1 square by 2. So it will be 2 by m1 u1 square. Put 2 by m1 u1 square. Then this one will give you this answer. m1 by m1 plus m2. m1 is m, this is 3m. So the result will become 1 by 3. When we are calculating, that final energy will be how much part of the initial energy. We are not calculating loss in this case. Okay. So if loss is required, then you have to calculate initial minus final divided by initial. Then it will give you the fraction of loss. This is the fraction of change. How much is converted? That is this calculation gives. Okay. Now we will check what will happen in case of perfectly elastic collision if we consider. Right. Now, see, again we are considering this situation, m1 moving with u1. This is the stationary mass. m2 is at rest because u2 equal to 0. Now we consider that after collision, m1 moves with velocity v1, m2 moves with velocity v2. Okay. We are considering perfectly elastic collision. Now what happens? The first equation that I can write from here is m1 v1 plus m2 v2 equal to m1 u1. Okay. For perfectly elastic collision, we can always write this one, that m1 v1 plus m2 v2 equal to m1 u1. Now, from this, I can write that what is m1? M. m2 is 2m. So it is m v1 plus 2m v2 equal to m u1, means v1 plus 2 v2 equal to u1. This is my first equation. Okay. We have another equation in case of perfectly elastic collision, that is relative velocity of approach equal to relative velocity of separation, means v2 minus v1 equal to u1 minus u2. So from that I can write v2 minus v1 means minus v1 plus v2 equal to u1. Okay. So this is my second equation. Relative velocity of approach equal to separation equal to relative velocity of approach. Now we can solve this to find v2. If we add simply, then we can write 3v2 equal to 2u1. So V2 equal to 2 by 3 U1. V2 equal to 2 by 3 U1. Okay. Just adding these two, this will cancel and this one will become 2 U1 by 3. Now if you substitute the value of V2 in any of this equation, you will get the value of V1. Find V1. V1 plus 2V2 means 4U1 by 3. That is coming U1. So it is V1 equal to U1 minus 4U1 by 3. So it is minus U1 by 3. Means the first particle is bouncing back because proton is alpha particle is twice that the mass of the neutron. So neutron after colliding will bounce back. That's why this sign will become negative. Okay. Now what is which quantity is asked in the question to calculate the loss in question lost in by neutron. Okay. So what is the final kinetic energy of the neutron? Half m1 v1 square. So final kinetic energy of the neutron is m1 u1 square. Okay. Now, so what is the loss? Then we can calculate. So if we want to calculate loss, means initial is greater, final is smaller. Check. Ki minus kf by ki, that is 1 minus kf by ki. It is coming 1 minus half m1 v1 square by half m1 u1 square. So half cancel, this one cancel. Now come to this. What is v1? Minus u1 by 3. So its square will be u square by 9. So put 1 minus u1 square by 9 by u1 square. So it is coming 8 by 9. And if you are calculating the fraction, it is just coming 1 by 9. Options may be wrong, don't go for the options. So these are all the procedures of the because in the problem the coefficient of restitution is not given, so we cannot consider the partially elastic collision. The other two types of collisions are there. One is perfectly elastic collision and perfectly inelastic collision. So both the procedures and all this we can calculate by this method. And if some particular case is given, that masses are given, then you can find out the ratios properly, because here we are doing some approximation. Neutron's mass is not exactly equal to the mass of the proton. Neutron's mass is not exactly equal to the mass of the proton, because neutron is slightly heavier than proton, and we haven't considered that. I think that the question should be not alpha particle, it should be helium atom. In that case 4 times and the options may match. It should not be alpha particle. Alpha particle is positively charged helium ion, and helium, if it is helium atom, then their mass will be 4m, then probably the answer will match. Okay, write down. Part 2 questions. Part 2. A body of mass 0.5 kg, a body of mass 0.5 kg
Question number, sir.
2. A body of mass 0.5 kg travels in a straight line with velocity v equal to k x to the power 3 by 2, k x to the power 3 by 2, where k equal to 5 meter per second square, k equal to 5 meter per second square, and x is the displacement of the particle. The work done by the force during its displacement, work done by the force during its displacement from x equal to 0 to x equal to 2 meter is, x equal to 0 to x equal to 2 meter is option A 1.5 joule, option B 50 joule, option C 10 joule, option D 100 joule. 50 joule.
120. 120.
50. এটা আনলে কি করে এটা E ইকুয়াল টু ভি ডিভি ডিএক্স, তারপরে ভি এর জায়গায় এটা বসালে কি ডিভি ডিএক্স ক্যালকুলেট করেছো 3/2 এক্স টু দি পাওয়ার 3/2 মাইনাস 1 মানে হাফ হলো, তাহলে এটা হলো কে স্কোয়ার 3/2 4/2 মানে 2 হয়ে গেল কে স্কোয়ার। আচ্ছা, তারপরে এমই
ডাইরেক্ট ওয়ার্ড
ডব্লিউ ইকুয়াল টু
এইটা হলো অ্যাক্সিলারেশন, এইটা হলো ডিস্টেন্স, হলো মাস।
ফোর্সটা ভেরিয়েবল, ইন্টিগ্রেট করতে হবে তো। ওয়ার্ক এনার্জি থিওরেম ইউজ করো, অনেক শর্ট হবে। See, don't try to go for calculation of integral f dx to calculate the work done. It will take too long calculation.
Is it option B, sir?
B. How? Tell me.
F dot S, sir.
F dot S. Okay, fine. Then how you get that?
I don't think it's correct.
I don't think it is correct.
The way I did it, sir. 2 minus 0.
No. F is 25/4. At which point F is 25/4? All the time. See, V is variable, acceleration is variable, so F is variable. So you cannot say F at a particular point. F is a single constant value. F is a variable force. See, I can show you two methods. First one, it is given that V v equal to some constant k into x to the power 3 by 2. See, v equal to some constant k x to the power 3 by 2. Now from this, you can calculate acceleration a by taking dv/dt. Okay, so if I take dv/dt, then we will get acceleration a. So it will be k into 3 by 2 x to the power 3 by 2 minus 1. 3 by 2 minus 1 is half into dx dt. But what is this dx dt? Dx dt means v. So I can again substitute this v. So it will become a equal to k into 3 by 2 into x to the power half into k x to the power 3 by 2. Okay, instead of that dx dt, I can again put v. Now it will become a equal to 3 by 2 k square x to the power 3 by 2 plus half means 2. Okay, so this is the acceleration. Now you can of course calculate force equal to mass into acceleration. So it will be 3 by 2 m k x square, m k square x square. Okay, then for the calculation of the work done, what you will do? Work done W equal to integral f dot f dx. X is varying from 0 to 2. So it will be 3 by 2 m k square, and then it is x square dx. Its integration is from 0 to 2. So it is 3 by 2. What is the mass given? 5.5 means half, and k given 5. So 5 square is 25 into this one will be x cube by 3. Upper limit will be 2 cube by 3 and lower limit will be 0. So it will be 8 by 3. What is coming? $50 joule. Okay, all of you understand?
So why don't we just multiply the force into the displacement?
Force into
Displacement
where?
and work.
Here. Why multiply?
Why can't we just multiply?
Why we can't just multiply? Why we have to integrate? Because this is a variable force. We can multiply only when it is a constant force. Variable force means taking small displacement, you have to integrate. Okay? All of you understand this procedure? But don't use it in exam. Even if you understand, there is more better way to solve this problem. How? Work done equal to change in kinetic energy. So it is half, mass is half. At x equal to 2, what is the value of velocity? K into 2 to the power 3 by 2 square. So it will be just half into, I will do one more step for you. half into mass into velocity square. Now that is the velocity, so its square will be k square x to the power 3 by 2 square, no more by 2. It will be x cube v square, half m v square, half m v is k x to the power 3 by 2, so its square will be k square x cube. Now when x equal to 0, what is velocity? 0. So nothing we have to subtract, final velocity is 0. Initial velocity is 0, initial 0. So only final we have to calculate, and final occurs at x equal to 2. Just put half, mass is half, k square means 25, and x cube is 8. What is coming? Directly it is coming 50 joule. Okay, so whenever this type of problem is given, before calculating integral f dx, try to solve it by using work energy theorem, because work energy theorem is applicable both for constant force and variable force. If you calculate simply f into dx, then for variable force you have to integrate. For constant force you can simply multiply, and work energy theorem you can apply always. Whether it is constant force, whether it is variable force, doesn't matter. Same theorem is applicable. So using that you can find the answer quickly. If you try to do integration, if you have too much time, you can do it. Okay, I will give you one problem. Write down, a particle is acted upon by a force. A particle is acted upon by a force F equal to F naught into 1 minus x by x naught. A particle is acted upon by a force F equal to F naught into 1 minus x by x naught, where F naught and x naught are two constants having the dimensions of force and displacement. Okay, calculate the work done by this force. Calculate the work done by this force in displacing the particle from x equal to 0 to x equal to x naught. means initial coordinate is x equal to 0, final coordinate is x equal to x naught. No option, and solve. One more part is remaining. Solve the problem without integration. Solve this problem without integration. I know that after seeing the problem, most of you will try to solve it by integration.
It answer is f naught x naught.
Cross check by integrating.
Zero, sir.
Half f naught x naught.
And how to find it without integration? Half f naught x naught. See, what is the power of f? 1. What is the power of x? 1. So can I write this equation like this? By multiplying this one, I can write the equation like this. It is similar to y equal to mx plus c, means equation of a straight line where slope is negative. So if you draw a graph, okay, this is force, this is displacement. Now this particular value is f naught, means this length is f naught. and this length is x naught. So force slowly decreasing. So what is the work done? Area under this curve means triangle. So that is half base into height. That is the work done. Okay. Because integration means calculation of the area under the curve. So whenever there is a linear function, the graph is a straight line, it is easier to draw and calculate the result from the graph rather to integrate. If you have higher power, then the area we cannot calculate without integration properly. But if it's a straight sometimes in some physics problem you may encounter some integration which seems to be very difficult, but there are certain properties of integration and certain properties of the function from which even without integrating we can find out the answer. Okay, so we will discuss one or two such problems. See, if force is given F equal to some F naught sine x, F equal to F naught sine x, and it is given that where x obviously is an angle now, or better to write, if it bothers, then we can consider also like this, F equal to certain kx, because then the dimension will match, because kx is the same dimension as that of the angle, because k means 2 pi by lambda, so it will be an angle, then there will be no such issue. Then suppose you have to integrate it from x equal to 0 to x equal to lambda, x equal to 0 to x equal to lambda, it is the displacement. Okay, how now k we can use 2 pi by lambda. Now whenever this type of calculation given and you have to calculate the work done by this force in displacing the particle from x equal to 0 to x equal to lambda. So normally what we will do, we will calculate W equal to integral 0 to lambda, F naught is constant, coming out it is sine, k means 2 pi by lambda into x into dx. Okay, and after solving you will get the value. Now calculate and tell me the value. Sin x dx, its integration will be minus cos x plus some constant, but constant is not required because it is a definite integral, minus cos x, but it will be sine, some constant is there, so then if it is sine kx dx, its integration will be minus cos kx by k, because that constant has to be divided. Or you can simply put 2 pi by lambda equal to k, and finally you can put the value of k. That is also possible. No need to write it here if it is seeing difficult. So write it as simply k, then complete the integration and finally put the value of k. See, if you calculate, then it will be f naught is there, sin kx dx, its integration will be minus cos kx divided by k, limit is from 0 to lambda. Done. Then f naught by k, this entire thing is taken common, f naught by k. I will also take common this minus sign, so it will be minus f naught by k. Remaining term inside will be cos kx, minus is taken common, so it will become cos k lambda. K lambda means 2 pi by lambda into lambda minus cos 0. This is coming. Now this one will give you cos 2 pi. What is cos 2 pi? Cos 2 pi is plus 1. Cos pi is minus 1. Cos 2 pi is plus 1. Cos 0 is plus 1. So both will cancel and the result will be 0. Now without doing this integration, you can write the result to be 0. Can you tell me why? Without doing all this integration, you can directly write this integration's result to be 0. How is it possible? Without doing the integration, how can we write that the answer will be 0? You have to check only one thing. What is the integrand? This one. Integrand is sin kx, right? So I can write f of x equal to sin kx. Now just replace x by minus x. What it gives? Sin minus kx. Now if there is any minus sign in the sine function, it will come out and it will become minus sin kx. But what is sin kx? So I can write f of minus x equal to minus fx. Means sin x is an odd function. Odd function. Sin x is an odd function. Any function which satisfies this condition that f of minus x will be minus of that function. then it is called odd. And when odd function is integrated over a symmetric limit, its integration will always be 0. You can check for cos kx, this result will not hold.
So then in case of 10, 10 is also odd function. 10, in case of 10 function also.
For any, suppose product of sin x into cos x, sin x into cos x, cos x is even but sin x is odd, odd even, their product is odd, odd into even, their product is odd. So this result holds always, because that is coming from actually the knowledge of integration. And if you plot the sine function, the graph is like this. So x equal to 0 to x equal to lambda, this is a complete wave of the sine function. Okay, now this area is in the upper half, this area is in the lower half, and remember in the cross product you have done, area is a vector quantity. So upper area is positive, lower area is negative, and integration means area under the curve. So this is the positive area, this is the negative area, but their values are equal. So the sum will be, as a result, the result of this integration will be 0. So first check whenever there is a odd function and limit is symmetric, complete period, always the result will be 0. No need to integrate, directly put the value. Okay, this is a property. If you use the property, you can save time from the calculation. Because if you check similarly for say fx equal to cos x, if you consider cos kx, just check similarly f of minus x, this will not hold this property, this is holding a different property. F of minus x will become cos of minus kx, but cos of minus kx will become plus cos kx. There will be no minus sign coming out, it will be cos minus kx, it is similar to cos kx, nothing will change, so it will be f of x. See, if there is argument is changed to minus sign, there is no change in the function, it will become again positive. Okay, now you can also say what is the graph of a cos x. Like this, from 0, so then this is from 0 to lambda, then again cosine x graph is like this, so on. Initially at 0 it will be maximum, then at 90 it will be 0, then at pi it will become this one, then again at 2 pi it comes here. Okay, so cos x is always even function, and another property is there for even and odd function. If you draw the remaining part of this graph on this side, this is the graph of the sin x. Just check, consider that this one is a mirror, and similarly draw the graph of the cos x and consider this one is a mirror. This is exactly mirror reflection, but that is not a mirror reflection, inverted mirror reflection. So this is the property of the odd function, and this is the property of the even function. For all even function, graph will be symmetric, and for all odd function, graph will be asymmetric. Okay, so this property, if you can remember, you can bypass the long integration to find the result directly using these properties.